Lenses have the ability to produce both real and virtual images, depending on the type of lens and the position of the object relative to the lens. Convex lenses, also known as converging lenses, are particularly versatile in creating different kinds of images. A real image is formed when light rays actually converge at a point after passing through the lens, and this type of image can be projected onto a screen. In contrast, a virtual image occurs when the light rays appear to diverge from a point behind the lens, making the image appear on the same side as the object, and it cannot be captured on a screen. To understand how a convex lens forms an image, one can use a ray diagram. Drawing a ray diagram for an image formed by a convex lens involves a few key steps. First, you draw the principal axis, a straight horizontal line that passes through the center of the lens. Then, place the lens in the middle of the diagram and mark its focal points on both sides, which are equidistant from the lens along the principal axis. Next, position the object above the principal axis, typically as an arrow pointing upward. To find the location and nature of the image, you trace at least two principal rays emanating from the top of the object. The first ray is drawn parallel to the principal axis, traveling toward the lens. Upon passing through the lens, this ray refracts and passes through the focal point on the opposite side. The second ray passes directly through the center of the lens, continuing in a straight line without bending. Where these two rays converge on the other side of the lens is where the top of the image will be located. By connecting this point down to the principal axis, you can determine the size and orientation of the image. The distance of the object from the lens significantly affects the characteristics of the image. When the object is placed at a distance greater than twice the focal length from the lens, the image formed is real, inverted, and smaller than the object. As the object moves closer to the lens but remains beyond the focal length, the image remains real and inverted but becomes larger. When the object is exactly at twice the focal length, the image produced is the same size as the object. If the object is placed between the focal length and the lens, the image becomes virtual, upright, and magnified, appearing on the same side of the lens as the object. This effect is why convex lenses are used in magnifying glasses and other optical devices designed to enlarge images. In summary, lenses, particularly convex lenses, can produce both real and virtual images depending on the object's distance from the lens. Ray diagrams are essential tools for visualizing and predicting the nature of these images, showing how light rays refract through the lens and where they converge or appear to diverge. The position of the object relative to the focal points of the lens determines whether the image will be real or virtual, its orientation, and its size. Understanding these principles is crucial in the study and application of optics.